Hi guys, hello, Mr. Butler here, back to share another lesson with you, this time on Key Stage 2 fractions, adding and taking away fractions we're going to do today. I say Key Stage 2 simply because it's not Key Stage 1, and by that I mean it is not a basic introduction to fractions. This is Key Stage 2, so you should already have a basic understanding of what fractions are, what numerators are, what denominators are, what your fraction line represents. So we're going past that into adding and taking away fractions today. What I do want to mention very briefly though is the denominator, and I want you to be very clear that the denominator kind of defines the fraction. It tells us what kind of fraction it is. So if it kind of tells us how big a piece of the pie we're talking about, how big a slice of the pizza we're talking about, so what part of the whole we are talking about. As you know, if the denominator is 4, we're talking about quarters. If it's 5, we're talking about fifths. If it's an 8, we're talking about eighths. So that is the definition of the fraction, if you like. But that also should make sense to you that we don't add denominators when we add our fractions. Please don't do that. But please don't. I'm begging you, because honestly, the quickest way to annoy your teachers is to start adding denominators. There's nothing we hate more. Please don't do it. You don't add denominators because the denominator is what that fraction is. It's a bit like saying I've got some oranges and I'm adding some more oranges and I'm going to end up with pears. No, you're not, because if you add oranges to oranges, you just get more oranges. Now, if you add quarters to quarters, you get more quarters. If you add eighths to eighths, you get more eighths. So they will still be eighths. So we don't add denominators. If they start off as eighths, they will finish off as eighths. So please be aware of that. Now, initially, if I bring my whiteboard up here, we'll talk about examples where they are very nicely asked with the denominators that are the same, so we don't have any playing around to do whatsoever. So, for example, if we have 3/8 and then we add another 2/8, they are going to stay as eighths. This is not going to become 16ths. There's no magic here. Eighths plus eighths will give us eighths. It's Mr. Butler's school. It's not Hogwarts. So this is going to be eighths always, and you've got 3/8 plus 2/8, so you end up with 5/8. Similarly with subtraction, if you have 9/10 and you took away 3 of those tenths, then you would have 6/10 remaining. So tenths, 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 the denominators will stay the same. But as you know, we do not always have a situation where our denominators are the same. Sometimes we have to play around a little bit. Your first examples that I'm going to show you now are ones that do have different denominators, but they are at least in the same number family. Those denominators are in the same number family. Let me show you exactly what I mean by sharing my screen again. So, for example, if I had 3/4 and I was adding 4/8. Whenever you see a problem like that, you need to think, I can't add these together at the moment, not in this form, because the denominators are not the same. All right, I've got quarters here and I've got eighths there. But your second thought should be, hang on, 4 and 8 are in the same number family. So I can turn this 4 into an 8. What do? I obviously times it by 2. I double it and it becomes 8. Now, you can't just go around changing denominators because you feel like it. You need to make an equivalent fraction. It needs to be the same size of fraction, but obviously represented slightly differently. So if I'm going to times 2 the denominator, I also have to times 2 with the numerator. So my new fraction down here is 3 times 2, which is 6, and 4 times 2 here, which is 8. So I've got 6/8, and now I can add it to my second fraction. So I've just brought this one down here to my 4/8, and it gives me 10/8 altogether. So 6/8 plus 4/8 is 10/8. Some of you might be saying 10/8 is an improper fraction. My very next video that I'm going to post will be about converting from improper to mixed numbers and from mixed numbers to improper fractions. So I won't go into that now, but 10/8 is a correct answer for that particular problem. Similarly with subtraction, if I have 8/9 and I need to take away 8/18. My first glance, I say, okay, the denominators are not the same. I cannot subtract them in this format. I need to try and make the denominators the same. So if I times this one by 2, then it will be 18, same as the other one. But I can't do that without also timesing the numerator by the same amount. Whatever I do to the bottom, I have to do to the top. Whatever I do to the top, I have to do to the bottom. Otherwise, they're not equivalent fractions anymore, and I'm just making up numbers, so we can't do that. So this is eventually going to become 2x is 16/18, and then we're taking away our 8/18, and of course, we're going to be left with 8/18. So change one fraction to match the other one if the denominators are different but in the same number family. If they're in the same number family, you only have to change one of them. Harder still is when we have different denominators but they're not in the same number family, so we can't just multiply one to match the other. That is a bit more tricky. So let's have a look at a couple of examples of those and see what we do. Let's just clear that. So let's imagine that we've got thirds and fifths, for example. 2 thirds plus 3 fifths. Now, I first notice my checklist through my head is, are the denominators the same? No, they're not. Are they in the same number family? No, they are not, because I can't multiply 3 by anything to make it become 5. So they're not in the same number family. So what do I need? I need a completely different denominator which works for both of them. It works for 3 and it works for 5. That is called the lowest common denominator, the LCD, lowest common denominator. Now what the lowest common denominator is the lowest number that is in both of these times tables. Both of them. So I've got 3s and 5s. So I can start writing my 3s down here. 3, 6, 9, 12, 15, 18. My other denominator is 5. So let's write our 5s. 5, 10, 15, 20, 25. Some of you will have spotted it already. 15 is here and in here. So the lowest number that is in both of those times tables is 15. So that is the lowest common denominator. So that is going to be our new denominator for both of these fractions. Okay, now we said earlier, you can't just change the denominator because you feel like it. You've got to make an equivalent fraction. So this denominator here started life as 3, now it's 15. What did we do to it? We actually timesed it by 5. In that case, we have to times the numerator by 5. 2 times 5 is 10. So our new numerator is 10. In this fraction, we started life at 5 and it became 15. So we actually times it by 3. So we're going to have to times our numerator by 3. 3 times 3 is 9. You will see now I can add my two fractions together because the denominators are now the same. They are both 15. 10 fifteenths plus 9 fifteenths is 19 fifteenths. That is the answer to my question. Yes, it is top heavy. Yes, it is improper. And as I said, look out on my YouTube channel for another video on converting improper to mixed, because I'll be doing that one next. So those are the 3 scenarios that we've looked at. So I'll just go through those 3 scenarios very quickly for you again. Firstly, the scenario where the denominators are already the same, that's cool, they're already the same. We can just add them or take them away. So we just add or take away our numerators. Secondly, where the denominators are different, but they are in the same number family, like 4s and 8s or 3s and 6s, where one of them perhaps we can just times it by 2 to match the other one. We're still getting the denominators the same, but that's nice and easy. And then thirdly, when they are not in the same number family, then we might need an LCD, a lowest common denominator, which remember is the lowest number that is in both of the times tables. Don't be afraid to just write your times tables down the side of your page if you were in a test, for example. Nobody cares if you do that, but you can very quickly see which is the lowest number that is in both. That becomes your new denominator, but then just remember, whatever you've done to the denominator to get that new one, you also have to do to the numerator so that we're talking about equivalent fractions and we're not just making up numbers. I hope that is clear. I've got some examples for you to do. I'm going to put them on the screen now. If you then pause the video and have a go with them, I will then go through the answers with you. Give them a go. So here are those questions now. There they are. Have a little go. Pause the video, and I am about to give you the answers. Okay, good. Thank you for trying those. If you did, I appreciate it. Let's. It will help you. The more you practice, the more you consolidate this kind of learning. Let us go through the answers on the whiteboard here. I believe the first one was 5/7 plus 3/4. So let's just have a little play around with that. The first thing we notice is that the 7 and the 4, different denominators. They're not in the same number family. So we need the lowest number that is in both of these times tables. 4, 8, 12, 16, 20, 24, 28, 32. Let's have a look at the 7s. 7, 14, 21, 28. Oh, there we go. Here's a 28 and there's a 28. So the lowest number that is in both our times tables is 28. Notice that I just put the 28 directly underneath the two fractions. I can then think, okay, I've had a 7 denominator, I've now got a 28. So I have timesed it by 4. You can look back here, look, and go 1, 2, 3, 4. You can look at your times tables to work out how many you need to multiply by. Similarly, 4 became 28, and we did 1, 2, 3, 4, 5, 6, 7. We times our 4 by 7, so we times our numerator by 7. This was times 4 up here, wasn't it? And 3 times 7 is 21, and 5 times 4 is 20. So we're adding 20 plus 21, which is, of course, is 41 over 28 would be the correct answer. Look out for the video where we are converting this into a mixed number. So that is the first example. So let's just clear that and look at the second one, which was 8/9. This is a subtraction one. Now you need to know that subtraction works exactly the same way, other than the fact that we're taking away, but the process is the same. 9 and 8 are our denominators. What is the common denominator for these two? 9, 18, 27, 36, 45, 54, 63, 72, 81, and then our 8s go 8, 16, 24, 32, 40, 48, 56, 64, 72. There it is. So our denominator is 72. Take away another fraction with a denominator of 72. 9 times 8 is 72, so this is times 8. 8 times 8 is 64. 8 times 9 is 72, so this is times 9. 5 times 9 is 45. 64, take away 45 is, and if you weren't sure, you could just come over here and go like this, 64, 45. Again, don't ever be afraid to scribble on your test papers. Let's cancel out here 5. 14 take away 5 is 9, and this is 1. So our answer is 19 over 72. Don't forget to take away. That's often a common mistake. So that's the second example. Let's clear that. And your third one was 2/3 take away 1/4. 3 and 4 not in the same family. Let's do our 3s. We won't have to go very far with this one. 3, 6, 9, 12, and you should know that 12 is also in the 4 times table. So our denominator is 12. Take away another fraction with 12. This to get 12 is times 4, so this has got to be times 4. This to get 12 is times 3, so this has got to be times 3. 2 4s are 8, and 1 3 is 3. 8 minus 3 equals 5 5/12. Sorry, I was speaking a little bit quickly there, but hopefully by the third example, you are seeing the method. So 5/12 is the answer. So please just remember that addition and subtraction are effectively the same. There's no new rules other than the fact that you're taking away when it's a minus. There are no new rules. You're still looking to match up your denominators by finding the lowest common denominators when you've got numbers that aren't in the same family. I hope that helps. Please keep an eye on my YouTube channel, because the whole of this summer holiday, summer 2020, I'm going to be posting several a week, so they will build up, and a lot of them will be directly relevant to you. I'm going to be doing different year groups and different key stages as well, so keep an eye on it, because there'll be lots up there. And subscribe to it. It's great. And then we can communicate, and you can ask me questions, and there may be videos that you want to see that I can put together for you. So I look forward to hearing from you. Take care for now. Bye.